This video is to review 5.5 material. In 5.5, we talked about how to name covalent compounds and then also how to name our acids. Every time you want to name a covalent compound, you want to make sure you're using your prefixes. This prefix chart will not be given to you on the test, so you do want to memorize the prefixes. There are a couple of rules that we keep in mind. We always want to name the first atom and add a prefix only if there is more than one of that atom. The second rule is name the second atom and then always add a prefix before the second atom. And then make sure you're using the ending, which is "-ide". So our first example over here is we have H2O. All right, the way that we name our H2O is that we know it's water. So what you're going to do is you're going to write dihydrogen and then monoxide. Therefore, this 2 represents this di, and then we know after oxygen we only have one of them, so that's monoxide. The second example is PCl5. You don't put a prefix in front of the first atom, so therefore you just write it as phosphorus. Right? This 5 indicates that you have 5 chlorines, therefore you need the prefix penta. And then you're going to change the ending to "-ide, so that's going to be chloride. N8O9, you have octa, nitrogen, nana, oxide. And this is how you name covalent compounds. The difference is when you have something that's an acid, all right? Acids always have hydrogen as the cation. All right, so you always want to look at the ending. So if it ends in an "-ide, like this, right, you always want to name it as hydroblank ic acid. If the ending is ate, you want to just write ic acid at the end. And then if the ending of the anion is ite, you want to write os acid. So we're going to practice writing our formulas for these couple examples. So the first one we have is our hydrochloric acid. And hydrochloric acid, we know it has this "-ide in front of it. And right, since acids always have hydrogen as the cation, we can write our hydrogen down right over there. Right, our chlorine. When you look on the periodic table of elements, hydrogen has a +1 charge, chlorine has a -1 charge. Therefore, our formula is just going to be HCl. Right, our carbonic acid. Our carbonic acid, you're going to look on your periodic table. You're going to look at your polyatomic ion chart. You're going to look for ic acid. All right, so the ic has been changed to ate. So you're going to look for a carbonate. When you look for carbonate on your chart, you can see that it has an anion of CO3 -2. Right? Our hydrogen always is +1, so when you balance out the charges, your entire formula is going to look like this. H2CO3 for carbonic acid. Our sulfuric acid, the OUS, has been changed to ite, so you're going to look for sulfite on your polyatomic ion chart. When you look for that, it's going to say SO3 with a -2 charge. We know hydrogen always has a +1 charge, therefore our formula is going to look like H2SO3 for our sulfurous acid. Every time you have the acid, you want to name it. All right, you want to look for the anion, which is the ending over here. So here we have just F. All right, we know that comes from the periodic table, so we can name it as hydrofluoric acid. All right, the second example, NO3, you're going to look for that on your polyatomic ion chart. When you find that, you're going to see that it's nitrate. Because the ending is ate, you know to change it to ic acid. So it's going to be nitric acid. Right? When you look for NO2, in this case, it's going to be nitrite because that ending is nitrite. When you look for a nitrite, you see it has an ending of ITE, therefore you have to change it to OUS. So when you write the name of the acid, it's going to be nitrous acid. Right? If you still need help, look at your notes, look at your PowerPoints, and then come ask me. Thank you.